Hello everyone, welcome back to Infinity Physics. In the last lecture, we had a discussion about plane mirror, reflection of light, types of reflection, and the characteristics of the image formed by a plane mirror. In this lecture, we will discuss about spherical mirrors. So in the picture, you can observe that we have two mirrors. In the first mirror, the image of the object is smaller, while in the second mirror the image of the object is larger. Why does this happen and how these kinds of mirror we can prepare? So all these things we will see in our next slide. So here you see that two types of surfaces of a spoon are there. In the first surface you can see it is curved inwards. It is like this part is reflecting, the reflecting part is curved inwards, and in this part you can see the reflecting part is curved outwards. So the mirrors in which, suppose this kind of glass we have and we paint it from this side. So if this part is painted, outer part is painted, then the inner part is reflecting. So the mirrors in which the reflecting part curves inward are called concave mirrors, and the mirrors in which the reflecting part is curved outward, this part is reflecting like this, right? So this type of mirrors in which the reflecting part is curved outward are called concave mirrors. Here we assume that the mirrors are a part of sphere. So this is our original sphere of glass and then we cut it, right? And after cutting it we take this slide and then we cut it from this side and we take this slice. And now suppose we are remaining with this slice and we paint it from outer side. So here we have applied some paint from on the outer part. So here at this part we have applied paint. So this part is reflecting. So here you can see what are concave mirrors. The concave mirror is a spherical mirror which has its reflecting surface curved inward. So this part, this inner part is reflecting. And what are convex mirror? The convex mirror is a spherical mirror which has its reflecting surface curved outwards. So this surface is reflecting like in the spoon, right? So this type of mirrors in which the reflecting part curved outward are called convex mirror. Now our mirrors are made from an imaginary sphere and the sphere has their center. So our mirror has its center and the center of the imaginary sphere is called the center of curvature. So here the center lies this side, but in case of a convex mirror the center lies on the other side. So we will see the other terminologies related to the mirrors. So what is the center of curvature? The center of curvature of the sphere of which the spherical mirror is a part. So our spherical mirror is a part of some sphere. So its center is called its center of curvature. Curvature means curved surface. And as this is a center, so the distance between the center point and the point at the end of the sphere is called the radius. So what is radius of curvature? Radius of curvature is the linear distance between the pole and the center of curvature. This is pole and here we have center of curvature. Center of curvature is a point and radius of curvature is a distance between center of curvature and pole P. And what is a pole? Pole is a midpoint of this spherical mirror. This is our spherical mirror, not the total mirror. This is the reflecting surface, right? And the center of this reflecting surface is called pole. And the line joining an imaginary line, which is not actual but it is imaginary line joining pole and center of curvature, means this is pole and this is our center of curvature. So we'll draw an imaginary line. So this imaginary line passing through the pole and center of curvature is called principal axis. Here the other terminology is principal focus. What is principal focus? Principal focus is a point on the principal axis where a beam of light parallel to principal axis after reflection either actually meets or appear to meet. So here we have our curved surface, and this is our principal axis. So the rays coming parallel to principal axis, after reflection they gather at a particular point. At that point they get focused. So this point where they get focused is called principal focus. If you cannot imagine, you can see this picture. Here I have the parallel lines, parallel rays from a source, and after reflecting from this concave surface they are converging at a particular point. They get focused at that point, and hence that particular point is called principal focus, where they get focused. Now the principal focus of a convex mirror, if we have a surface like this, right, this kind of surface we have, and here is its center, because convex mirror has its center inside the mirror, an imaginary center, and this is our principal axis. So the rays parallel to principal axis when strikes, so this surface is bulging like this, so rays will not go this side, and instead of going this side, the rays will go this side, right? So if we join all this ray at this point, we will get an imaginary focus. So the the principal focus of convex mirror is imaginary, it is virtual, it is not real, it is behind the mirror. So this point, that is the rays which are diverging, see, after reflection they are going, they are diverging, here they are converging, they are focusing at a particular point in case of a concave mirror, hence we call this mirror is a converging mirror. But here after reflection all the rays are diverging, that is going in different directions, and when we join them we get a particular point, and that point where they appear to meet, they are not actually meeting, so this point is called the principal focus of a convex mirror. And what is the focal length? Focal length is nothing, it's a distance between the principal focus. See, principal focus is a point and the focal length is a distance. So this is our principal focus and this is the pole. So the distance between the pole and the principal focus is called focal length. So here also in these two mirrors, this distance from the principal focus to the pole is called focal length. Here this distance from principal focus to the pole is called focal length. And what is aperture? Aperture is nothing but a diameter of the reflecting surface. That is the size, the length of the reflecting surface. This is the diameter, this is the length of the reflecting surface. This length is called aperture. Similarly, this length, this distance is called aperture, the diameter, the length of the reflecting surface.